Greetings! Did you ever wonder what's going on inside your electrolytic capacitors and your interstage capacitors and your vacuum tube projects? And maybe when you're repairing some of the old equipment, the old radios, amplifiers, and such. I had wondered a little bit about leakage, what's going on and what the difference is there between new and old. And I ordered a PC board from Antique Wireless Supply and built this little leakage tester. It's pretty nice. It works real good. You have your voltage monitoring, your microamp leakage, on and off, switch in the back, test and discharge switch there, and your voltage adjustment. It goes up to well over 500 volts, so it works pretty good. And if you connect your voltmeter to it, actually 1 volt equals 1 milliamp. So when you get down into the scale, as on my 1 meter, when you're reading the 2000 milliamp scale, you're actually into the 2000 microamps, and then down lower the 200. So you can read the microamps pretty good. And I'm just curious of what it should be, what it shouldn't. And I found an old chart from an old tester that lists the acceptable back in the day with some of the voltage in microfarads. And I have a couple things I wanted to test and find out. I have a old 1960s can cap from that Magnavox radio that I recently did. You can look up that video. And I have a brand new, well, it's been sitting on my shelf for a year. It's a can from CE Manufacturing that I actually used one of these, exactly the same. I've had 2 of them in that Magnavox radio. And what's interesting is if you go over to eBay and you look up CE capacitor, can capacitor manufacturing from Amplified Parts, they have a really nice series of videos where they show you exactly how they make these the old way. They recovered old Mallory equipment from Mexico, restored it, and they take you through the process of how they still make these by hand. That's why they're expensive, and test them. Also, I have a couple capacitors I wanted to look at just real quick. I repaired a JVC receiver. You can look at that video. And they had some 35 volt 6800 microfarad caps in them. And actually I found some new old stock exactly the same with the 3 leads, which is really hard to find because all the new caps, the bases are smaller. So the wires fitting into the PC board, you have to go make them fit. But these ones I didn't have to, and they work great. And I tested a couple of them, and I had a couple old caps. I don't have any paper caps to show you, paper and wax, which I have a Philco radio that I'm going to start soon. It has those in it, but I have the ones I pulled out of that Magnavox. This is ceramic hard coating on there, and I'm not sure who the manufacturer is, just says Type CT. And I have one from Dart. This is a plastic encapsulated capacitor, and interesting. I'll show you the difference of the insides of these later on. But let's look at that and look at the leakage. And I know, particularly in the interstage capacitors in your tube amplifiers, you really want the lowest leakage you can get. And electrolytics, they're going to be a higher leakage, and they're going to take a longer bit of time as they charge up for that leakage to stabilize and drop. It's just how they act, which is no big deal. And a lot of people talk about the ESR. I don't have an ESR meter, but doing what we do with old radios and vacuum tube amplifiers, do we really need to be concerned with that in power supplies? I don't think so, because If we have a high ESR, you're going to know it. You're going to hear humming because it's gonna mess up your power supplies. I think leakage is more important, especially testing. If you want to test one of them, pull one out, and actually see what's going on with them, maybe life of them. I don't know. But let's move on real quick, and we'll take a look at some of these, what I come up with, just to show you, give you an idea of what goes on inside with the leakage. I have a couple different meters connected up. For the microamp reading, I have a digital on the left there, and I have a vintage analog from Radio Shack. It's a really good meter. This was new old stock that I found a couple years ago, and it works great. They did make a couple versions of this. They made this one and one that went down on the voltage, DC voltage scale. This one only goes down, has a down to 1 volt scale, but they had one that had a 0.5 volt scale on it also. Now these are field effect front ends, and they're very accurate, and I like it. But the capacitor on here is a vintage capacitor from about 1963 that I took out of that Magnavox radio that I recently repaired. You can check on my other videos if you wish to see that. But I had this connected up, and I'm going to run around close to, it's running a little bit over 300 volt right now. And I am going to probably keep that voltage on these other caps. I just wanted to show real quick. Now you can see the microamp reading on this. Now this has been on powered up for about a half hour, and it's jumping around. Sometimes it drops down. You can see it's 208 microamps, 209, then it goes back up to 112, 14. So that's about as good as it's going to get. And that is kind of high for over a long range. But we'll look at one of the newer cans also that I have. I have a newer CE. Actually, this has been sitting on my shelf for about 2 years. That's from CE Manufacturing. But one thing goes to show you, these old can caps, this one still was in a circuit. It still worked in that radio, but the leakage is starting to get up there. It should be a lot lower. If you look at the chart that I have, this is actually from a Sprague tester, leakage tester, vintage speak tester. But if you look down, that is a 40 microfarad. And if you go down, you can look on the chart between 30 and 50, and we're running up. It's a 350 volt capacitor, but I have about 300 volts onto it. And you can look at the acceptable microamps at that microfarad, and it's really surprising. For a 30 microfarad, the acceptable microamp leakage is at 300 volts is 329 microamps. So this is lower. So that makes you wonder the shape of these capacitors. Now, I know one of the things that always damaged capacitors in old vacuum tube equipment was heat. So some of these cans must be pretty well made, being this one was made from 1966. And the leakages where it's at is really surprised me. I thought it would be a lot higher. Now, when you connect these up, the leakage, of course, is higher as it charges. But I was surprised about that one. I don't have any real old damaged ones to look to see, but I have a couple other things. But let's pop in the, now I had this on powered up for about a half hour. So the leakage actually goes down. It's interesting just to see. The leakage will drop over a period of time till it levels off. I'm going to connect up the new CE. Now this is a 50 microfarad, 350 volt. This is a newer one. And actually, this is what I had used in that as a replacement in that Magnavox radio. So let me connect that up, and I'll leave it on for a while. We'll see what that does, just for comparison. So the new can cap, it's been on there for about 20 minutes. And again, we're running at 300 volts. As you can see, it's bounced around between 79, 80 microamps, and it may drop a little more than that. But it's interesting about that chart I showed you from the Sprague capacitor tester on what was the acceptable limits in microamps. Again, if we look at, this is a 50 microfarad section, and we're running it at 300 volts right now. So the maximum limit there, it's telling us is for a 50 is 735 microamps. But of course, this is way down lower, which I suspect because it's newer. But I wanted to look at a couple more old electrolytic. I have one that I pulled out of this that JVC receiver. Now this is a 6800 microfarad 35 volt. I pulled that out of the JVC receiver. There was actually two of them in a power supply that I repaired, and he was actually using it with these in. But the measurement was around 4,500 microfarads on my meter, what the actual measurement was. So these did lose out some. Let's pop that in real quick, and let me run that up, and I'll let it run for about 15-20 minutes, and we'll see what that shows. So we're running this around 35. It popped up close to 40, but we can go back down a little or not. Hold on a minute. But you can see it settled at around 180 some odd microamps. It's just bouncing around there now. Just gives you an idea of this. As I said, it lost some of its value because it's supposed to be at least 6,800, and it dropped down to 4,500 on the meter, showing what the value is. And I do have to tell you that what I replaced those with, these are old stock, but they have never been used, 6800. And if you notice, they've got this same crazy setup with 3 leads where I've never seen this before, where the center lead actually helps support the capacitor on the board. So you're not going to find new ones made like this. And also in that particular size, the new ones, the base is a lot smaller, so the pins, leads won't line up properly. But I found these and I bought some of them. Actually, I put some of them on eBay for resale because I really don't need them all. I had to buy a bunch of them to get them for that amplifier, that JVC, but they work great. But I had this one on for about 45 minutes charging up, and the microamp leakage dropped down to 2.10, which is not too bad. Not too bad for something as vintage as this. But my meter popped off here. But I also wanted to talk a little bit about, we use capacitors in our amplifiers, interstage, and mostly for transmitting audio signals between the stages. You'll have a capacitor in there. So I wanted to look a little bit about some of those. I have a couple. I don't have any real old ones. I do have a few old ones now. These are out, I have a couple that are out from that Magnavox radio. Sorry I sound like a burro. I set my microphone down over here. Let me clip it back on. Okay, there we go. And but these aren't paper. The wax, you know, they have the wax on them. These are like a ceramic. I'm not quite sure, but I opened them, broke a couple open, and this is what was inside the white ceramic. And it looks like it's just foil, and actually, there's an oil between the foil and this one. You can smell it. There's an oil in there. So that's interesting. And these ones don't read too bad, but these are 200 volt capacitors. You run the scale up there. Make sure that's down. And let's look at the leakage, because this is where you want really low leakage on your capacitor, especially, you know, for audio in your between your stages. Excess leakage is going to really make a difference in your audio signal. Now, I'd be curious to test some of the boutique capacitors, but of course I don't have any of those. But this is a 200 volt, so we're going to run this up a couple hundred volts here on the scale. And look at the leakage. Now, this is 1963. I do have some old paper and wax, but they're still in that old radio filco that I have to do. And we're looking here at 189 microamps leakage there. So you really wouldn't want that as far as a capacitor in anything that's delivering your audio in say a tube amplifier. That's quite high. Now, maybe because it's old, but I have one on here that really surprised me. This was another one that I pulled out of that Magnavox, and these are sealed in plastic. These are Dart. This is a 0.22, 200 volt. I'm going to put that on here. And I think this is the one that surprised me because of its age. And one thing I noticed about this one, I opened one up, and this one looks to be no oil, but it has a plastic, whether it's Mylar or whatever they used back then, between the foil. There's a plastic insulation between, where that one in the white ceramic actually had an oil. So that's interesting. So putting this one up, this is also a 200 volt capacitor. Interesting enough, would you look at that? Basically no leakage. That capacitor has aged very well. There's no leakage in that capacitor at all. And it really surprised me. And I have one more I want to look at. I have a newer Mallory 150p, which I've used these in my amplifiers with no problems. The 150ps, a lot of them, they seem to work fine. But let's put that one in, and it'd be interesting to see what this one does. Take it out of discharge, put it in charge. Let's run this. Now that's a 630 volt. We can actually run that up even higher. Let me change the meter here. Go to the 1000 volt range. And I can run that one up all the way. Let's take it up to 600 volts. .600 volts. And here comes Doobie. Doobie, stay away, buddy. High voltage, kitty. He's back there rooting around. He likes boxes. Let me grab him. Come on, bud. You don't need to be up there while there's electricity on. Come on. And if we look, we're down to 3.6 microamps on that newer Mallory 150. And I checked out some other Mallories that I had. Generally around the same, about 3 microamps. But again, what really surprised me was this old Dart capacitor. Again, this had like a Mylar in there, but no leakage, really good insulation inside. So there you have it. Is what it is. Just to give you an idea of what's going on in your capacitors with leakage. So other than that, you have any questions, comments, go ahead and leave them. And have a good day, and God bless.